All right, so today we are going to be subdividing a segment. And I can divide a segment into a specific ratio if I'm given a specific ratio. So let's take a look at some ratios. So if we were doing 1 to 2, so I want to break up a segment from 1 to 2. So we look at that, and if I have a segment, I want to probably break it up right about here, because if we break it up into 3 segments, 1 out of 2 is my ratio. Now, when we think about that though, what is the total number of segments? Yes, it's 3. So when I actually write a 1 to 2 ratio, I would take my segment and times it by 1/3. And now generate that same idea for 2 to 4. And if we do that, look what happens. So we have 2 out of 1, 2, 3, 4. And 2 of those out of 4 of those. What's our total? We have 6 total. And if I were to times my segment by 2 over 6, isn't that the same as timesing it by 1 over 3? So these two actually have the same ratio. Pretty cool, huh? So how does that apply to us? Well, if we're given a segment, and we could do the distance formula and times it by the ratio, surprise, surprise, it's 1 to 2, which we know we would times it by 1/3. So we want to add these two together. That's how I get the 3. So I would do 1 plus 2 and then use this number as my top one. So that's how I'm getting this answer of 1 to 3. So we could find the distance formula and we could times it by 1/3. However, we don't actually have to do that. We can separate it between the x's and the y's. Ooh, it didn't change color on me. So when I look at this and I separate it, well, how many jumps are on the x? So we have 1, 2, 3. Oh, funny, isn't that what we just did? And if we want 1 to 2 ratio, we only need to hop once. So when I look at this, I'm going to color in one of these, and that's where I stop. I stop right here, okay? And then if I look at the bottom, I'm going 1, 2, 3, 4, 5, 6. Well, funny enough, 2 out of 4 is going to be 1/3 again. So we're going to color in 2 of these. And when we do that, we create this. And where do these 2 lines intersect? Right here, which would be, let's call it C. And then that breaks up our segment A to B into a 1 to 2 ratio. And what's that ordered pair? Well, start at 0, 0 and go back -1, -2. And then we're going to go up 1, 2, 3. So that would be my point. I guess they said P instead of C. So let's stay consistent. And we'll call this P. Pretty wild, huh? So let's try that again. And you can reapply this every time. And if we want to show the math between it, let's look at the x's. The x's, how many jumps did we have? We had 1, 2, 3. So we are going to take 3 and times it by 1/3, which is 3 over 3, which simplifies to 1, which is why we only jumped one space. And if we look at the y's, same idea. We had 6 of them, times it by 1/3. That's going to be 6 over 3, which simplifies to 2, which is why we jumped 2 spaces. And we jumped 2 spaces from A. So we could have put the point P here, or if, yeah, we could have actually done the other way too and done it here. So there are two different solutions, but I would always start with the first point that they give us. All right, so let's try this again. Let's separate it into x's and y's. And first off, before we do anything, what's our ratio? So our ratio is going to be the first number, 3, over the two numbers added together. So this will be 3 over 5. That's going to be our ratio. So we're going to times this by 3 over 5, and we're going to times this by 3 over 5. So let's break it up again. Once again, let's find out how many jumps it takes us to get from A to B. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Gosh, I don't know. That seems like an awful lot. How do we do that? How do we do that? How do we make that easier on ourselves? Because, man, do I want to do all of this? Probably not. So, how would we do that? Well, let's take the x's and add them together. Add them together. And what I mean by that is we have the jumps from A to the 0 and then 0 to the B. So you want to take the absolute values of your x values and add them together, and you should get 10. Because if I do 4 jumps and then I do 6 more jumps, even though they're in the negative direction, they're still a jump, we can add those together. So I want to do 4 plus the absolute value of -6, which comes to be out 10. Then that gives us 30 over 5, which comes out to be 6 jumps. So if I do that, 1, 2, 3, 4, 5, 6, here is my line. Now let's try it with pink. So once again, we counted all of these y values. We counted all of these y values, and we ended up getting 15. So let's go back to our idea again. If we do 2 plus the absolute value of 13, because we jump down 2 spaces to get to 0 on the y-axis, and then we jump down another 13, that total gives us 15. So if that's the case, then 3 times 15 is 45, divided by 5, that should give us 9. So then we jump down 9 spots. So if we do that, 1, 2, 3, 4, 5, 6, 7, 8, 9, we would end up right here after 9 jumps. And you could color them in if you want, however you like the game. And you can see they both intersect at our point P, which would be -2, and then 1, 2, 3, 4, 5, 6, 7, -7. Yeah, maybe. It seems like a lot, but once you get some practice in, it's just about understanding your jumps. Okay, so now we got A here and B here. And first, let's find our ratio. So take the first number, 3, over the total number, 3 plus 1, which is going to be 3/4. So we're going to break it up into 3/4. So at this point, let's go with our x's. And if we don't do our jumps, let's just try this without it. So we're going to do the x's and add them together. So -8, the absolute value of that is just 8, plus 8 is 16. Then let's times it by our ratio, 3/4. So I need 16 times 3, I don't know, hold on. 16 times 3, and I just don't want to do it incorrectly. I can do the mental math, but if I make a mistake and then that's what my video shows, not good form. All right, so then that's a 12. So that means I'm going to jump 12. Well, if I get on my x-axis, that is, so I'm going to get 6, or I'm sorry, I'm going to get 8 right here because A is -8. So that's 8 jumps right there. 9, 10, 11, 12. So here is where I start to create, and I'm going to guess this is where it is, but we need to double check. We can't just assume that. But let's assume that P is going to be 1, 2, 3, 4, and then 1, 2. 4, 2. And how did we get that? Well, take your A value and add your X to it. So if I take -8 plus my X value, because we don't actually need graph paper. That's what we're trying to get away from. That's what we're gonna do. We're gonna take our A value and add our answer to it. So let's see if that's gonna work for our Y's. So let's switch to pink, because that's what I've been doing the Y's in. So the first thing I want to do is take the absolute value of my Y's, and that's going to be 12. I hope. Sometimes. Too much static electricity or something, I don't know. I wish it would, right? Love that for me. Okay, so 12, and then we're gonna times it by our ratio, so times it by, now it's just kind of comical, huh? What is going on here? 3/4. Help me help you. 3/4. So then that's going to be 36. That's kind of funny at this point, huh? Oh my gosh, what is going on here? Okay, let's click off this and see if we can get this working a little bit better. So we'll have 36/4. Actually, that's what I'm going to do. I'll unplug it, try and plug it back in. Interesting. And it equals 9. So we're going to take our 9 that we get and add it to our A value. So that A value is going to be -7, which ends up turning into a +2. Surprise, surprise. That's what we get right there. So it's all connected, and you don't need graph paper. However, I'm sure graph paper does help, but you can do this without it as well. In my classroom, you will always be offered graph paper, but if you didn't, this is how you would approach that. All right, so from J to M, 1 to 9. So we're going to start here, J to M. So find the coordinate point P that divides the segment into the given ratio. So that means we want 1 out of 10. So every 10 So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would move us here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would move us here. So we have 2 sets of 10. So we have 2 sets of 10 that get us from J to M. And if we're doing 1 out of 9, so we're going to pop 1. So that's going to take us to negative 11, negative 12, and negative 13. Ooh. So what's the secret behind that? Let's try another one. So K to L is 1 to 2. So for every 2, we're going to move 1. So we break it up into 2s. So okay, so 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. So let's do this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll take our ratio and times it by 11, and that's going to give us 11 over 2, which is, oops, not 6, but 5.5. So that means from K, we're going to move 1, 2, 3, 4, 5, and a half, which end up getting us to, oops, negative 0.5. That's ugly 0.5. All right, let's try that again. There you go. Now, from K to N. So let's go K to N. So K to N, this is 18 from 0 to here, because here's 20. So 18. So then it would be 1, 2, 3, 4, 5, 6 added on. So we'll do 18 plus 6, which is 24. And times it by our ratio, which is 10 over 12. We could simplify our fraction if we want. However, let's just do 240 divided by 12. Take our calculator, 240 divided by 12, and we're going to move 20 spaces. So out of those 24 spaces from K all the way to N, we're going to move 20 of them. So we could actually just move 1, 2, 3, 4 spaces back and figure out if M is 10, 11, 12, 13, 14. So this should be equal to 14. That's our point P. This is our point P. And this is RP. All right, last one, J to M. So here's M, that's 10 jumps. Here's another 10 jumps, so that's 20, 21, 22, 23, 24, 25 spaces times 4 out of 10. And 4 quarters is $1. So we are just going to jump 10 spots. So from here, jump 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be our p-value, which if we jumped from 10 and we were 5 here, so that would make us negative 5. A lot of jumping around, a lot of different situations going on. Just remember, you're going to take your ratio and times it by the distance between the 2 points. And if you do that every time, you will get what you need. So how do we do this with story problems? Same idea. A gardener uses a number to position plants in the garden. Plants A and B have the coordinates 5 and 23 respectively. Find the coordinates for each of the following plants based on the given locations. So from plant A to plant B, we're going to use a 5 to 6. Now understand, in our number line idea, we start at 5 and we go to 23. So this time we're not adding our terms together, we're actually going to subtract them, because in between 5 and 23, there's not 28 spaces. There's technically only 18. So if we were to jump between here, there would only be 18 spaces. Then we multiply it by our ratio, which is 5 to 6. So we're going to take that 18 and times it by 5 over 6. And that's going to give us 15. So this is 15 jumps from A. So if I take A and I jump 15 spots, we'll take our A value, which was 5, add our jumps, which is 15, which gets us to 20. So our P is going to be at 20. And that's where we're going to put our plant. And that was plant C. So now, if our plant D stands at a 2-to-1 ratio, so that will be 2 out of 3 is our ratio. And once again, we still have the 18. That's not going to change, right? And then we'll do 18 times 2/3. And that's going to give us 12. So we'll take our A again, which was 5, add 12 to it, which now gets us to 17 jumps. Or, I'm sorry, so we did our 12 jumps. Let me label this jumps. Label this jumps. And that gets us our position at 17. So on our number line, if we started here at 5, and then here is 23, plant D now would hit at 17. So these aren't straightforward. It's a little tricky. It takes a little bit of, okay, I'll go with it. But the more practice you get on these, the easier they become. They really do. So keep working at it, keep trying, rewatch the video, do whatever you need to do, ask questions, get help. But we can do this. All right? Like and subscribe.